In this problem, we're going to multiply this factor and this factor together. So let's see how we can do this. Now, according to the rules of multiplication, what we could do is multiply straight across the top, straight across the bottoms, and then reduce. But then 15 times 35 could be a big number. 7 times 33 could be a big number, and then trying to reduce that could be difficult. So what we'll do instead is we've already got these things partially factored, right? So why don't we just start canceling any common factors that we can see right now. I'm going to rewrite this because when I start canceling, I'm going to start drawing some lines, and if I have lines all over the place, it's a little difficult to see what happened. All right, so let's see what we can cancel here. So first of all, I can see that 7 will go into 35 5 times, and then this m down here, and I got 2 m's up here, so this 1 m here will cancel with one of those. And now let's take a look at this 15 and the 33. Both of those are divisible by 3, so let's make that division. So 3 will go into 15 5 times, 3 will go into 33 11 times. And now let's do our best to put this all back together without losing anything. We've got 5 times m times 5, so we'll have 25m. And in the denominator, we've got a 1 times 11 times 1. That'll give us an 11. So let's conclude then that that is the multiplication in simplified form. So problem number 5, I'm going to do this pretty much the same way as we did number 3. I'm going to rewrite this first of all because I'm going to start drawing those cancellation lines, and I want to be able to see where I started and then what's left. So let's redraw this. Okay, now let's see what we can do about canceling. Well, first of all, we know we've got a negative times a positive, a positive, a positive. We've got an odd number of negative signs, so this whole result is going to be negative. So we'll remember to put that negative on when we get to the end. But now what we'll have is this. I can see this 4 will go into 4 once, 4 will go into 16 4 times, 5 will go into 5 once, 5 will go into 25 5 times. So here's how I'm going to do this. I'm going to see this as negative 1 times 5, so I'm going to write that as negative 5, and then what I've got is this. I've got these z's, so I've got 6 of them here and 6 of them here. I'm going to go ahead and multiply those together. So I'm going to get 6 plus 6 is 12 over, now in the denominator we'll have 1 times 4, so we'll have a 4 down in the bottom there, and then we'll have z. Now we've got 3 of them here, 1 of them here, so all together we'll have 4 of them. Now doing it this way is just a little easier, at least for me, to keep track of how many z's I've got. So what I'm going to have here now is this. We're going to have negative 5 over 4, and then how many z's have we got here? Well, I've got 12 on top, 4 on the bottom. So these 4 on the bottom will cancel with 4 out of those 12 on top, leaving 8. So we'll have z to the 8. Number 7. Everything's factored here already, so let's go ahead and see if we can cancel any common factors. So first of all, I can see this one. Now there's no order that you have to do this in, but I can see this. This 2 will go into 2 once, that 2 will go into 10 5 times, and then this 5 will go into that 50 10 times, and then this 5 will go into that 10 2 times. So that's a lot to keep track of, so we'll be careful with those lines that we draw. And now I can see this one. This C plus D, I've got 1 of them on the top, and I've got 2 of them on the bottom. So this 1 on the top will cancel with one of these 2 here on the bottom. And now, hoping I don't lose anything, here's what I've got left. I've got a 1 times 2, so I've got a 2 on the top. And on the bottom, what have we got here? Well, 1 times 1, I got a C plus D, so it looks like just a C plus D. Let's move on now to number 11. Let's see, it looks like everything's factored here, right? Everything's in factored form. So let's start our canceling. I can see that this t plus 9 is going to cancel with that t plus 9, so those t plus 9s are gone. Then this 6 will go into 6 once, it'll go into 24 4 times. You know, and I think that's it. We've got some t's on the top, but none down here on the bottom. So I think we're left with just a t squared on the top, and on the bottom, just that 4. In number 17, this problem is a division, right? We got a division. And division, what we do is we multiply, change the division to multiplication of the reciprocal. I learned it a long time ago as invert and multiply. So let's invert this divisor over here. We'll get 49 x to the 9th over 7x to the 10th times, now invert this one, 5x cubed over 7x squared. Now I'm going to start canceling with these numbers first. Here's what I know. Well, look at this one. You got a 7 times the 7, that's 49. That'll cancel with that one. We're going to be left with that 5 on the top. So actually, I'm going to write this like this. I'll do it over here. We'll get 5, and then what do we have on the top here? We've got x to the 9th and x cubed. That's x to the 12. And in the bottom, we cancel those 7. So in the bottom, we've got x to the 10 plus 2, which is also 12. And then you can see that these x to the 12s are going to cancel. So we're left with just 5. So we're saying that 7x squared over 5x cubed will go into 49x to the 9th over 7x to the 10th 5 times. Now number 21, we've got a division here, so the first thing I'm going to do is invert this divisor and change the division to a multiplication. So this will give us 5 over x minus 2 times 5x minus 10 over 30. Now I can see that I'm going to multiply here. What I'm going to do is I'm going to factor as much as I can. I can see that I can factor a 5 out of these two terms. So let's do that. So we'll rewrite our 5 over x minus 2 times, now we'll factor a 5 out of here, and we'll be left with x minus 2 all over 30. And now let's start our cancellation. So we can get this 5 will go into 30 6 times. This x minus 2 will cancel with that x minus 2, so here's what I think is left. We got 5 times 1 times 1, so on the top we're going to be left with a 5, and in the bottom we're left with a 1 times 6, just a 6. So I think that thing turns out to be 5/6.